Okay, so this is a brief introduction to the latest version of UFOCFD, the octree version. So it's now got variable surface refinement, so you can specify the number of STL files you want to use, and then you can specify the refinement on each of those separate STL files. So that means you can take your geometry and split it up into different parts and have different refinement on different parts. So in this example, I've got tornado geometry, which I've split into the body, the nose, and the wings. So that's about it really. So you've got your 3 different geometry files here. You can have any number of them and different levels on each one. And then other standard settings that are explained. Most of it's self-explanatory. You've got the background mesh level, and you've got the number of blanket layers, and you've got some octree limits and the size of the root cell. So yeah, so we've got, this is the octree.txt input file. Then obviously you need to have your STL geometry, and then you need to have the octree solver, which is this octree.txt file. So you can run that, and that literally uses the STL files to create the octree mesh. So it goes through various stages of doing the STL refinement, and then the background mesh, and then the blanket refinement. And then after it's done all that, it basically calculates the neighbours and then writes the file. So this takes about half a minute to generate this one. Then you can open that. So that's the octree.btk file that gets created. So when you open that, you can look at the octree mesh just by creating a slice through it. And at this point you can actually get rid of the original geometry, and you can use the octree mesh and the distance field. So what you do is, from the BTK file, you cell data to point data. And then what I prefer to do is to clip the main based on a scalar, and that scalar is the distance field. And then select inside out, and that has clipped our mesh based on the distance field. So that is that's the surface of the tornado geometry based on the distance surface. So you can, because there's some thin surfaces here, I'm going to increase that value a little bit, and that shows all of how the geometry has been captured by the octree mesh. And then you can have a look at it, and in this case here, I switch the surface off. You can see the different refinement levels, because you've got a finer mesh at the nose, and you've got slightly coarser one on the wings, and then you've got the lowest level on the aircraft surface. And you can also see that as well if you switch on the levels. You can see how the aircraft has been split up. And if you surface with edges, then you can see the actual surface of the aircraft. And then following on from that, you would just change the number of iterations to say 1,000, and then run it again. And then when you run it, you don't have to run it twice, but when you run it with some iterations, then basically creates the octree mesh first of all, and then the solver starts immediately. That's finished. So this is doing the neighbour refinement, the blanket refinement, and it marks the mesh. Then it creates the points, and then it calculates the neighbours. And as soon as it's finished calculating the neighbour cells, then it starts the flow solve. And so you can see straight away that the flow solver starts running. So this has done 20 iterations now, and that is that's quite quick because this octree mesh is 1.6 million cells, so it's going through that fairly quickly. So that's a very brief introduction to the latest version of UFOCFD.